Good morning. My name is Sudhakar. So we have discussed about the lathe machines. In that we are going to end the session today. That lathe machine chapter will close today itself, right? So before going to start today's session, first of all we have to recall the yesterday's session, right? So what we have learned so far that have to be discussed. After the end of this today's lecture, we will recall all the topics what we have covered so far. Okay? That will be also discussed in today's session. So completely we are going to end the lathe machines chapter today, right? So now, so to start this today's session, what we have learned so far that have to be discussed now, right? So, so this is the basic manufacturing technology that we have completed that lathe machine chapter. Today we are going to complete this lathe machine first unit in our basic manufacturing technology. It will be come in our third semester. Right. So in the previous class we have learned that what is copying lathe, right? What are the advantages around the copying lathe and the working principle of copying lathe? What are the features of copying lathe that have been discussed yesterday? And after that, we have discussed in the comparison between the lathes that, that are automatic lathe, semi-automatic lathe, engine lathe. So we have compared these three machines with some features. Okay? So based on this comparison, we are selecting one particular lathe machine for doing some particular job. Understood? So why we are comparing all these points yesterday? Because we have to select the correct lathe machine to do a particular job. So for that reason, we have compared these three machines. So before going to recall that comparison, first of all we have to recall the copying lathe, right? So topping lathe means it is one of the production type of lathe. So these are all coming under the types of production lathes. Topping lathe also coming under the production lathe. Understood? Right. So for production lathe, topping lathe. Topping lathe means we have already discussed that in our earlier lessons, in our earlier discussions, that it is having one device that called stylus, and it is equipped with some predefined or template. Okay, predefined or template part that is equipped within this copying lathe machine. So this copying lathe that stylus is traveled on the copying lathe on the profile of the predefined template. Okay, so on the same way, that with that same way, cutting tool is traveled on the workpiece, which has to be manufactured. Understood? So the copying lathe is having stylus. Copying lathe is having stylus, and it is traveled on the template. So based on that traveling of template, the cutting tool is traveled on the workpiece. Right. So this is the working principle of the copying lathe. So by doing this, we are getting the some profiles. Okay, what are the profiles? Screws, worms, gates, slots. So these are the profiles we are getting by using the copy. So why do we need to do this? Means if we want to do the complex shapes or any contour shapes by traditional methods like engine lathe, there is difficulty, but the difficulty is arising because of labor skill. So for this reason, we have developed this one of the type of production lathe. So in this carving lathe is one of the method to do the profile operations, right? So carving lathe is automatic lathe machine, semi-automatic lathe machine. So it is under the category of semi-automatic lathe machine. So semi-automatic lathe machine means there is a human intervention is there for loading and unloading the products, right? And now copying lathe advantages. It produces the products accurately, and productivity is more, and accuracy maintained, precision is there. So these are the advantages we are getting from the copying. In the same way, there is some limitations also. Copying lathes are suitable for small objects, and in this we have mentioned that template. We have mentioned about the template. So template means it is already developed piece, masterpiece. So if we want to do the uh, products based on this masterpiece, first of all we have to develop this masterpiece in another machine. So it is difficult. You know. So this is the very uh, drawback in this copying lathe machine. Understood? So in this copying lathe, we want to develop the products based on the masterpiece. So that masterpiece have to be developed by other process. So it is very difficult to produce the. It is very difficult to develop the that product within other process. So this is the major limitation. But the productivity is increases, productivity is more, and accuracy is good, and complicated shapes and profile shapes can be manufactured based on the copying. Understood? And now, after that, we have discussed about the comparison between the copying lathe, comparison between the automatic lathe, semi-automatic lathe, and engine. So, based on some points, we have discussed these lathe machines. So, first of all, can we recall some of the points based on that rank? In this, automatic lathes are in the position of highest rank, semi-automatic lathes are in higher rank, and engine lathes are in the lowest rank, based on their ranking position. Product Production rate ranking position. It is not ordinary ranking position. Production rate ranking position. Production rate means products are produced within less time. So it is highest in automatic lathe machine, and medium range in semi-automatic lathe machine, and very high in very low in engine lathe. Okay, and after that, um, tool holding capacity. In automatic lathe, it can hold 30 tools at a time, but whereas in semi-automatic lathe, it can hold 10 to 15 tools at a time, and whereas in engine lathe, it can hold 4 tools at a time. So to hold in automatic lathe, to hold 30 tools, we need 3 to 5 tool posts, right? In semi-automatic lathe, to hold 10 to 15 tools, we need 1 or 3 tool posts, and in engine lathe, 1 tool post is enough. In automatic lathe, 3 to 5 tools operate simultaneously. In semi-automatic lathe, 1 or 3 tools operated simultaneously. And in engine lathe, 1 tool post operated. Sometimes we can operate the drill bit. It is stored in the tailstock. Okay, right. And after that, power requirements. So power requirement is 10 times more than the engine lathe in automatic lathe. Compared to the engine lathe, the power requirement is 10 times greater than the automatic lathe. In semi-automatic lathe, 5 times greater than the engine lathe, right? Compared to the engine lathe. So in engine lathe, the power requirement is less as compared to the automatic lathe and semi-automatic lathe, right? Spindle speeds. Highest spindle speeds are available in automatic lathe, that is 3000 rpm. Medium spindle speeds are occurred in semi-automatic lathe, that is 1500 rpm, and in engine lathe, 900 rpm speed will be we will get. Okay, so these are the power spindle speeds, and after that, based on that production of work, automatic lathes are suitable for job production. Semi-automatic lathes are suitable for batch production, and engine lathes are suitable for mass production. Right? Engine lathes are suitable for. Sorry, I have wrongly written this. Actually, the automatic lathes are suitable for mass production. Engine lathes are suitable for job production, and semi-automatic lathes are suitable for batch production. So in automatic lathes, there is no human intervention. In semi-automatic lathe and automatic lathe, for loading, for setting tool and setting workpieces, the human intervention is there. Whereas in engine lathe, entire work is done by the human, right? Skilled labor. So based on this point, skilled labor is needful in engine lathe. In automatic lathe, there is no need of skilled labor, right? In automatic lathe and semi-automatic lathe, there is no need of skilled labor. And after that, we can produce high precision works and low inspection jobs, low inspection workpieces, high accuracy workpieces, high production rate, that will be done by the automatic lathe. Whereas in semi-automatic lathe also, the inspection is done randomly, and high accuracy workpieces we will get, and high precision will be get in semi-automatic lathe. But in engine lathe, the accuracy is depends upon the skilling of the lathe, skill working of the labor, and we have to inspect every workpiece, because in engine lathe the workpiece is manufactured based on the labor, right? So that's why we have to inspect all the products which are produced by the engine lathe. Okay, so these are the comparisons we have done yesterday itself, right? Now we are moving to today's session. Okay, the previous class we have learned that comparison of engine lathe with semi-automatic lathe and automatic lathe, selection of suitable lathe for a given job. So based on these comparisons, we can select the suitable lathe for a given job, and also we have discussed about the copying. right? Now we are moving to today's session, right? On completion of this period, we would be able to review the importance of production lathes, right? Types of production lathes, advantages of production lathes, applications of production lathes, right? So this is our last topic in these lathe machines. We will review and we will close this chapter lathe machine today, right? So what we have going to learn now, the importance of production lathes, types of production lathes. We know already the types of production lathes. We don't know about some of the advantages we have. We know that will be uh, collected now, all the production lathes, right? Advantages of production lathes and applications of production lathes. Importance of first point is the importance of the production lathe. So we have to improve the production rate. Importance. Why we are developing this production rates? That is the main point. Here, first we have to discuss. That means if we want to improve the production rate, right? Production rate means we know already within the list time we have to produce more product as compared to the engine. Okay, so that's why this point is come in our mind. That is, we have to improve the production rate. That is the first point we have to know. Improve productivity. So more number of products. Production rate means it depends upon the time. Productivity means it depends upon the products. Okay. So production rate, within this 1 hour we have to produce 90 products. Okay, some example, let us take some example here. Production rate means we want to produce 100 products within the 1 hour time. So if we are produced that 100 products in 1 hour, that will be is our production rate or 90. If we produce 90 products also, it can very good production rate because we are mentioning with the time. But productivity means number of products are produced. How many number of products are produced? So this is also the importance of production layers. And quality, we know already this quality is a very important point nowadays because the customer need the quality product, and at the same time we have to reduce the cost also. If we are increasing the quality, uh, the cost of the product also increases. So to balance these, right, we have to maintain the quality and demand cost of the product. Okay, so high quality. So based on the other machining operation, other lathe machine operations, engine lathe, the quality is depends upon the skilled labor, right? The labor is not working properly because it is coming to the workshop at morning session, and uh, he spend 8 hours, right? So the morning session work will be run smoothly, but because of fatigue, because of cyclic load, so some defects are occurred some of the products. So it reflects the quality, right? So that's why high quality also is one of the important point to increase the to develop the production needs and reduce human involvement. I have already told you that if we want to improve the quality, we have to reduce the human involvement. the human involvement is reduces, the quality is improved, right? The quality is improved. So uh, all operations have been done by the human machine itself. So that's why I have told you that buckling. I have told you that machine complicated jobs. So complicated jobs. If you want to manufacture the complicated jobs, so these are the importance of production lathes: improve production rate, improve productivity, high quality, reduce human involvement, machine complicated jobs. Right. Next, we know that the second point is types of production lathes: semi-automatic lathes, in that turret lathe, capstan lathes, automatic lathes, and tool room lathes. So these are the types of production lathe. We know already about the turret lathe. The turret lathe is having turret head in that the tools are fixed. Okay, in capstan lathe, it is also similar to turret lathe, but in capstan lathe, carriage is fixed on the ram. So for longitudinal movement, if the ram is moving, we are getting the longitudinal movement. Automatic lathes. In automatic lathes, we know already we have discussed so many things about the automatic lathe and tool room lathes. That is the production lathe, right? Types of production lathes and special purpose lathes. Special purpose lathes means these are used for machining specific types of jobs. Special purpose lathes are suitable for specific types of jobs. Copying lathes that we have discussed yesterday's session. Copying lathe, chucking lathes, right? So chucking lathe means is also a automatic lathe, but in this tail stock is replaced by turret. Tail stock is replaced by turret. So these type of lathes are called chucking lathes, right? So copying lathe we know already is a tracer element, and based on the tracer element we are getting the profiles, right? Required profiles we are getting based on this copying lathes. And another types of production lathes: numerically controlled lathes, computerized numerically controlled lathe machines. So as we know about the numerically controlled lathes, in this a punch tape is there, in that the program is punched with the holes. So based on this program, it will be run the machine, it will run the actuators. So based on these actuators, the machine will work. Okay. Next, computerized numerical controlled lathe machines. So these are also similar to the numerically controlled machine, but in this the punch tape is replaced with the computer program, right? So what are the changes we need, or uh, we want to do some changes on this lathe machine, right? We are doing some operations, and we are uh, uh, changing the program based on the production demand requirement of the customer. So that will be the advantage in the computerized numerical control, because we can change the program at any time, any place, right? So that program will change the production operations. So Here the advantage compared to the numerically controlled machine. Whereas in numerical controlled machine, the tape is already punched. With that punched tape, the machining operation has been done. So no other changes has done while doing the operation. If you want to change the production, right, uh, we have to change the entire tape for the new product. So that is the disadvantages compared to the NC machines. And about the CNC and NC machines, we will discuss in our third year, fifth semester in CAD/CAM subject. In that, it is having separate subject is there, separate chapters is there. In that, we are discussing about the details about this numerical control and the CNC. So the CNC and NC is having some special types of features. Special actuators are there. Number of actuators are increased in this NC and CNC machines. So based on this actuators, these are running. Okay, because it all the works are done by automatically. So that's why here actuators are playing the main role. So, can we recall all the lathe machines? So, semi-automatic lathes are production lathes with human involvement for certain operations, and it is designed for short continuous runs, turret or ram in place of tailstock, indexable square tool post on cross track. So, this is semi-automatic lathe points. Semi-automatic lathes are some human involvement for certain operations that we know already for loading and unloading purpose, and these are designed for short continuous runs, right? These are designed for short continuous runs. Turret or ram in place of tailstock. Within that turret, we are having six tools. You can fix six tools at a time. So, right, and indexable square tool post on cross slide, and another square tool post on cross slide we can fix, that is indexable square tool post, right? So this is the semi-automatic lathe, and suitable for drilling, countersinking, reaming, tapping like operations. Examples are turret and capstan lathe, right? We know that the semi-automatic lathes are suitable for drilling operation. Drilling means producing the holes, counter sinking, right? Enlarging the hole with certain depth. Reaming is the finishing of the hole. Tapping means producing the internal threads. So, like operations I have done on the semi-automatic lathes. For examples of semi-automatic lathes are turret and capstan lathe. In turret lathe, the turret moves along with saddle. In capstan lathe, the turret slides over the ram, as I have told you about the in capstan lathe, the turret is fixing, the turret carriage is fixed on the ram for longitudinal movement. It slides over the ram, whereas in turret, the lathe turret moves along the saddle. Automatic lathes. Manual machine controls replaced by various mechanisms in automatic lathes like NC and CNC machines. Here the human intervention is not there. So all other controls are replaced with mechanisms, and all these mechanisms are operated by actuators, right? So that's why manual machine controls replaced by various mechanisms. Parts are fed and removed automatically. In this also, in semi-automatic lathe, the parts are removing and fed by the human intervention. But whereas in automatic lathes, parts are fed and removed automatically. So that's why automatic lathes are no involvement of humans. And in automatic lathes, it is having a single or multiple spindles. We have learned these things in our last session also. May have single or multiple spindles. And here operating sequences will be carried out by cam or actuator. Operating sequences will be carried out by cam or actuators. Simultaneous multi features operation is the common feature. Simultaneous multi-feature means operations are done by simultaneously one by one, right? Are one operating at another side and one is operating at another side. So simultaneously, more number of operations have been doing. So this can be the good feature in automatic lathes. In automatic lathes, without air stocks are called check-in machines. Okay, we already know that automatic lathe without air stock we can call it as check-in lathes. So automatic lathes are suitable for mass batch production, and it is having number of attachments available, work loading magazines, cross drilling attachment, polygon turning attachment, slot milling attachment. Understood? It is suitable for mass batch production, and in this, a number of attachments are available. Workload magazines, cross drilling attachment, polygon turning attachment. These are all the points we have learned, but we can recall today we are going to in our session. That's why we have been recalling, right? So automatically it's having workload magazines, cross drilling attachment, polygon turning attachment, slot drilling attachment. Copying lathe, we have already discussed this copying lathe. Copying lathes are suitable for intricate shaped parts such as pistons, worms, shafts, right? Masterpiece surface properties dictate entire batch production, right? So here the masterpiece plays the important role in copying lathe, so that the masterpiece surface properties dictate entire batch of the production. If the surface is not good, the products of the batch of the copying lathe will not get the proper products. So that's why masterpiece surface properties dictate the entire batch of the production. And copying lathes mainly doing the duplicate or any desired number of pieces. The profile tracer follows the outline of a sample one. So this is already we have recorded today's session about the copying lathe in our earlier class. Copying lathe duplicate any desired number of pieces. A profile tracer follows the outline of the sample one piece. And coming to the advantages of production lathes. So we know already some of the advantages, right? So that is high production rates, and it is useful for machining in more than two axes possible. We can do the simultaneous operations. That's why it can operate more than two axes possible. In generally, the axes are Z and X axis. The workpiece is rotated in Z axis. The cutting tool is moving in X direction. So in these two directions, the production lathes are operating. General production lathe. Apart from these two axes, the production lathes can operate more than two axes, right? So that's why we are telling that it can operate simultaneously, right? Inspection sometimes not necessary, right? Production lathes sometimes here the human intervention is not there. No need of skilled labor. Everything is done by the operations or automatically or based on the program. So for this reason, we don't need of human intervention. So for that, we are getting the accuracy products and precision products. So for these reasons, we are getting uh, good products. So but because of that, inspection is not necessary at all time. Okay? We can check randomly, or, or we can avoid the inspection also sometimes. We can avoid the inspection also. Number of operations can be performed simultaneously. As I told you that because of it can operate more than two axes. So that's why the number of operations can be performed simultaneously, and at the same time it can hold the more number of tools. That's why it can operate simultaneous operations. And so many turrets, tool posts are mounted on the production lathes. So by that we can hold the number of tools at a time. We can hold the number of tools mounted at a time. And the number of jobs can be machined simultaneously because the production lathe is having multiple skills, not it is having single skill, right? So for that reason, number of jobs can be machined simultaneously because it can hold the number of jobs. So that's why number of jobs can be machined simultaneously. And increase in productivity, we know that number of products will be produced, right, compared to the internet. So with this production rate, productivity increases and decrease in unit cost. So here some of the interventions are deleted because we are not paying the labor charge here, and maintenance cost is also less. So that's why here the unit cost, the production cost also decreases, right? Production cost also decreases. So increase in productivity and decrease in unit cost. And accuracy is also improved. We know that accuracy is improved because there is no human intervention, there is no need of skilled labor, and there is no static effect. All these considerations leads to the improve the accuracy. All these considerations leads to improve the accuracy of the product, right? So these are the advantages, and also less wastage through automatic controls, right? By using the automatic control means some of the operations need human intervention, but in this production unit, all operations are replaced with some of the controls, automatic controls. So because of these automatic controls, less wastage happens. So less wastage through automatic controls. Controls, more resources utilization with better safety. So we can use the resources, adaptation, and all other improvements are better utilization and also safety. It is in a closed content and there is no operator involvement sometimes. So more resources utilization with a better safety is happened in production lanes. And reduction of human involvement. We know already this point has been covered that human involvement is reduced. Job setting time is minimum or negligible. So here the jobs are setting time is minimum. Sometimes it can be negligible. So we are using some of the different products for holding the workpieces. So for that reason, job setting time is minimum, and sometimes it is negligible. Okay, so that's why production is having that advantages. Job setting time is minimum or it will be negligible. Complex contours like spirals may be prepared easily by doing with engine lathes. Some of the contour shapes, intricate shapes, not possible. So based on this production lathe, we can use these complex contours like spirals, and they may be prepared easily. Uh, we can tell that the copying lathes are suitable for these types of operations, and mass or batch production targets may be easily achieved. Mass productions or batch production targets may be easily achieved by this production lathe. So these are the advantages with the production lathe. Once again, we can recall them. Uh, in production lathes, number of operations can be performed simultaneously. Number of tools can be mounted at a time. Number of jobs can be machined simultaneously, and increase in productivity, and decrease in unit cost, and improved accuracy. Right? Increase in productivity, decrease in unit cost, improved accuracy. Less wastage through automatic controls, more resources utilization with better safety, reduction of human involvement, job setting time is minimum or sometimes it can be negligible. Complex contours like spirals may be prepared easily, so it can be done by the copying lathe. And the last advantage point is mass batch production targets may be easily achieved. Now we are moving to applications of production lathes. So for performing operations on special jobs, we are using production lathes, that is like tank shaft turning, wheel turning, camshaft turning, right? So these are the applications of the production lathe. In that, the feature is for performing operations on special jobs, tank shaft turning, wheel turning, camshaft turning. Applications of turret lathes, generally used in batch production. Similar types of operations is done on the workpiece, that is called as a batch product. That is called as a batch production. So the turret lathes are suitable for uh, batch production, and it is suitable for performing sequential operations like drilling, boring, tapping, etc. As I told in our discussions in turret lathe, the tool magazine is having 6 tools, so it is doing the operations like drilling, boring, tapping, etc. Machine medium size to large size jobs. It is useful for machining medium size to large size jobs. Okay, and applications of capstan lathe. It is ideal for fast production of small parts, suitable for batch production, and it is suitable for bar work also. Applications of capstan lathe. Ideal for fast production of small parts, suitable for batch production, suitable for bar work also. Applications of automatic lathes. The automatic lathes are suitable for mass production of medium to large size jobs. Sometimes it can be used in transfer lines, and it can be used in machining irregular shaped jobs. Mass production of medium to large size jobs. Sometimes they can be used in transfer lines, the machining irregular shaped jobs. Applications of copying lathes. They are generates copies profiles on the workpiece. Batch production generally used for turning of parts such as shafts, axles, piston rods. Okay, so these are the applications of the capstan lathe, tablet lathe, and copying lathe, and automatic lathes, right? So let us summarize today's session. In this session, we have learned about the importance of production lathes, types of production lathes, advantages of production lathes, applications of a production lathe. In this, we have newly learned points or importance of production lathes, advantages and applications of the production lathes. Okay, the types of production lathes as we have discussed so far till now. Right. So with this, we have concluded the lathe machine. Based on this, we can do some questions today's session. Select a suitable lathe for finishing a batch of medium-sized castings, capstan lathe, tablet lathe, copying lathe. So here the medium size means we are going to the tablet lathe, right? Select suitable lathe for generating profile. Profile means we are going on the copying lathes. Select suitable lathe for producing screws in large quantity. So quantity, so it means mass production. So mass production means it is automatic lathe, right? So if we have the knowledge of theory, we can easily answer the quiz questions, right? So I am not saying the object, I mean, options, but I am doing the quiz questions, right? Select a suitable lathe for producing screws in large quantity. Quantity means it gives the production, it gives the mass. So mass production means it is done by the automatic lathe. For that reason, I am easily tell this answer automatically. Okay. Select a suitable lathe for bar work. Bar work means it is done on the capstan lathe, right? So simple way we will answer the questions. Production lathes are suitable for job production, batch production, mass production. It is suitable for job production. Automatic lathes are automated with mechanical controls. The following may be regarded as semi-automatic lathes: chucking lathes, capstan lathes, copying lathes, capstan lathes. So these are the frequently asked questions. State the advantages of production lathes or conventional lathes. Write down the applications of production lathes. Write the features of production lathes. Differentiate between capstan and coupling. So with this, I have concluded this session, and also I have concluded the lathe machines. In lathe machines, we have learned so many things about the lathe machines, engine parts, parts of the lathe machine, construction features, sub holding devices, tool holding devices, types of lathe machines, advantages and disadvantages of lathe machines, right? And types of production lathes, and in that we are learning all the lathe machines, right? So by this, I have closed this today's session and also lathe machines chapter also. With that, we will